So I'll explain how to divide complex numbers. We will start by dividing monomial by monomial. So here we have the number 5 divided by 2i. To do this, what we do is we multiply both the numerator and denominator by I. Okay, so there we go. So 5 times I is 5i. 2i times I is 2i squared. But we know that I squared is equal to -1, which gives us 5i over 2, and in the bracket -1, because I squared is -1. So we have -5i over 2, because this would be equal to 5i over 2 times -1 is -2. And we just put the negative sign. You could put it in the middle, but generally we don't keep it in the denominator. So that's for the first kind of example. Now we go to the next one. So the next kind is where we divide a binomial with again a monomial. So here we have 2 plus 3i divided by, let's say, 5i. Again, in this particular case, we will, again, you'll see that in the denominator we just have I. So we all again divide it up and down with I, which gives us 2 plus 3i times I over 5i times I. Expanding and opening the brackets, we get 2i plus 3i squared, because 3i times I, over 5i times I, which is 5i squared. Again, we remember the identity, I squared is equal to -1, and substituting -1 everywhere that we see I squared, we have 2i plus 3, and in the bracket we put -1 over 5, and in the bracket we put -1 again, and that gives us 2i minus 3, because 3 times -1 is -3, and 5 times -1 is -5. You can rewrite this with either changing the sign, or you could write it like 2i minus 3 over 5. You could leave it like this, or you could take the negative sign to the numerator, which would give us a negative 2i minus and minus is again plus, so plus 3 over 5. Okay, if you're asked to write this in the standard form is a plus bi. So this can be written as negative 2i over 5 plus 3 over 5, right? You apply we just divide each term by 5, okay, which gives us now, because the real part comes first, so we have 3 over 5 minus 2i over 5, which is the imaginary part, although you could just leave it at this part and you are also done, right? This is just in case you're asked to write it in the standard form. The standard form is the complex number is z is a plus bi, where a is the real part and bi, that's your imaginary part. Okay, so now we go to the next type, which is dividing by a binomial. So it is 7 over 3 plus 2i. Now to do these kind of problems, what we do is we multiply with the complex conjugate. So what is a complex conjugate? The complex conjugate of 3 plus 2i is 3 minus 2i. 3 minus 2i. So now we multiply each of these with like 7 with the 3 minus 2i and 3 plus 2i with 3 minus 2i. So proceeding, we get 3 into the bracket 7 times 3 minus 2i over 3 plus 2i in one bracket, and the other bracket 3 minus 2i. Okay, now this requires us to remember one algebraic identity, a plus b, a minus b is equal to a squared minus b squared. So we'll be using this identity in the denominator, which gives us, now expanding the brackets in here, we get 7 times 3 is 21, 7 times 2 is 14, so you get 14i over, now remember this is the identity, so we have 3 squared minus 2i also is squared. So here the numerator is 21 minus 14i divided by 3 squared, which is 9, minus 2 squared, which is 4, and I squared is I squared. Again, we remember that I squared is -1, so we substitute that there, getting 21 minus 14i over 9. Now remember this is -1, right? So I'm gonna, okay, just add one more step to this. This is -1, which gives us 21 minus 14i over, this is now minus and minus, so it's gonna be plus, so 9 plus 4, okay? Which you can do 9 plus 4 over there and simplify the denominator to 21 minus 14i over 9 plus 4, which is 13, and then we got rid of the I in the denominator, so we rationalized the denominator. Right, so the last type is binomial divided by a binomial. So we could use, for example, 3 plus 2i divided by 5 plus, let us say, 3i. Right, now we have to rationalize this denominator or divide this complex number by this complex number. To do this, what we do is again multiply up and down with the complex conjugate, which happens to be 5 minus 3i over 5 minus 3i, which gives us 3 plus 2i in one bracket and 5 minus 3i over 5 plus 3i, and in another bracket 5 minus 3i. Again, we use the identity a plus b, a minus b is a squared minus b squared. So we come up, and here we expand the bracket, so 3 times 5 is 15 minus 3 times 3 is 9, so 9i. Now we do this multiplication, which gives us 10i, and then positive and negative, so negative 3 times 2 is a 6, I times I is I squared, divided by, remember to use the identity, which gives us 5 squared minus 3i also squared. So here now we combine like terms, so 15 minus 10 minus 9 plus 10 is just 1. We don't write 1, and it's positive because 10 is the bigger number and it's positive, minus 6i squared. Remember that I is -1, so you could just write I squared is -1, so just write that there. Okay, and here we have 5 squared, which is 25, minus 3 squared is 9, and we remember that I squared is -1. So here we have 15 plus I, the minus and minus becomes a plus, so you have plus 6, and down there we have 25, again minus and minus the plus 9, which gives us 15 plus 6, which is 21, plus I divided by 25 plus 9, which is 34, and again we can see that there is no I in the denominator, and we have rationalized it. Right, so that is it.